number is CN200102, and I will explain question 1 and question 2. Question 1. A scuba diver inhales a lungful 350 milliliter of air at a depth of 33 feet, where the pressure is approximately 2.0 atm and the water temperature is at 18 degrees Celsius. If the diver holds her breath, what will the same amount of air occupy at sea level, where pressure is approximately 1.0 atm and the air temperature is 35 degrees Celsius? From the question, we found out that V1, which is volume, equals to 350 milliliter, P1, which is pressure, equals to 2.0 atm, temperature, which is T1, equals to 18 degrees Celsius. And then we also found out that there is value for P2, which is pressure, equals to 1.0 atm, value for T2, which is temperature, equals to 35 degrees Celsius. So what left is the V2, volume that we need to find. From the question given, we know that there is value for pressure, volume, and temperature. So we can use the gas law, which is PV equals to nRT. But we do not need the N and R, so we eliminate them. So it becomes PV equals to T. Then we bring the T to the left. So the equation becomes P1V1 divided by T1 equals to P2V2 divided by T2. After that, we can put all the value given into the equation, which is P1 is 2.0, V1 is 350 divided by 1000, T1 is 18 plus 273. 350 is divided by 1000 because we need the volume to be in liter. And then the temperature, which is 18 degrees Celsius, must be in Kelvin. So that's why 18 plus by 273 to have the value of Kelvin. Then equals to P2, which is 1.0, V2, the value that we need to find, divide by T2. Same as T1, T2 also must be in Kelvin. So that's why 35 degrees Celsius plus by 273. So the value becomes 2.0 multiplied by 0.35 divided by 291 equals to 1.0 V2 divided by 308. Then it becomes 0.7 divided by 291 equals to 1.0 V2 divided by 308. The value becomes 0.7 over 291 multiplied by 308 equals to 1.0 V2. After that, the value becomes 0.7409 equals to 1.0 V2. And then we switch to make the calculation becomes easier. So it becomes 1.0 V2 equals to 0.7409. After that, we bring the 1.0 to the right to find the value for V2, which is V2 equals to 0.7409 over 1.0. So the final value for V2 is V2 equals to 0.7409 liter. Even though the question did not mention, but the value for V2 is also calculated in milliliter, which is V2 equals to 740.9 milliliter. Question 2. What is the volume in liter of 3.80 moles of CO2, which is carbon dioxide gas at STP? From the question, they want us to find the volume in liter. And we are also given the number of moles, which is N equals to 3.80 moles. And we also need to find the volume of gas at STP, which is standard temperature pressure. The temperature is equals to 273 Kelvin. Pressure is equals to 1 atm. From this, we can use the gas law. The formula for gas law is PV equals to nRT. R is a constant value, which is R equals to 0.0812. So by using the gas law, we can put all the value we found from the question, which is P equals to 1 atm, V is the volume that we need to find, equals to N, number of moles, 3.80, and R, a constant value, 0.0821, T, which is 273 Kelvin. And then, the value becomes 1V equals to, multiple all the three value becomes 85.1705. But we still need to find the value of V. So V is equal to 85.1705 divided by 1. So the final value for V is equal to 85.1705 liter.
Hey guys, my name is Fatin Nabila binti Dul, and I'm going to answer the question 3 and 4. For the question 3, what is the pH of 25 ml of H2SO4 are needed to neutralize 5.0 mole of NaOH? So firstly, we need to do balance equation. So we got 1 mole of H2SO4 when react with 2 mole of NaOH will produce 1 mole Na2SO4 plus H2O. So the value that has been given is 25 ml volume of H2SO4. So we need to convert it to liters. So we get 0.025. And the number of mole of NaOH is 5.0 mole. So we need to calculate the mole of H2SO4. So we do like this. 1 mole of H2SO4 equal to 2 mole of NaOH. So since the NaOH is 5.0 mole, so we multiply with 2 multiply with X. So we got 2.5 mole of H2SO4. Then we have to find molarity of H2SO4. We use molarity formula, mole over L. So set the value 2.5 mole over 0.025 liter equal to 100. This is the concentration of H2SO4. So 1 mole of H2SO4 have 2 H+. So since we want to calculate the pH, we need to multiply 100 with 2, so we get 200. To calculate the pH, we need to use the formula pH equal to negative log concentration of H+. So insert the value 200 in concentration H+, we got negative 2.301. So the answer is pH of 25 ml of H2SO4 are needed to neutralize 5.0 mole of NaOH is negative 2.301. Question 4 states, boric acid is frequently used as eye wash to treat eye infection. The pH of concentration 0.05 solution of boric acid is 5.28. Determine the volume of boric acid ionization constant. So the value given is pH and the initial concentration of boric acid. So this is the equation. So firstly we need to do ice table. So this is the initial concentration of boric acid. So this 0, 0. The change negative plus the equilibrium is 0.05 minus X. So we have the value of pH. So we need to find concentration of H+. So 5.28 equal to negative log concentration H+. So we got the answer, concentration H+ equal to 5.2481 multiply 10 negative 6. So we need to take in the approximation. by using the formula test equal to value of X over initial concentration multiply 100%. So put the value of X here, 5.2481 multiply 10 power of negative 6 over 0.05 multiply with 100%, so we got the answer 0.01%. So it is less than 5%. The approximation is success. Concentration constant, we use the formula Ka equal to X over the initial concentration minus X. So we enter the value of X and we got the answer 5.5085 multiplies 10 negative 10.
Good morning, Doctor. I'm Hiroja from Group 3. My metric number is AN200201. And now I'm going to proceed to question 5. A 10-gram sample of metal at 78 degrees Celsius is submerged in 50 milliliter of water at 25 degrees Celsius. The final temperature of the water is measured to be 26.1 degrees Celsius. Assuming no heat is lost to the surrounding, what is the approximate heat capacity of the metal when given that the specific capacity of water is 4.18 joule per gram degree Celsius? These are the values that we can find from the question. We are asked to find the approximate heat capacity of the metal. So, as Q system is always equal to 0, Q metal plus Q water is equal to 0. And we take the Q water to the other side. So we can say that Q metal is equal to negative Q water. So the first thing that we can calculate is the Q water. Q water is equal to Ms delta T. We can obtain the values from the questions. Delta T is final temperature minus initial temperature, which is 26.1 degrees Celsius minus 25 degrees Celsius. Then we can obtain the answer of 229.9 joule. From the equation Q metal is equal to negative Q water, we can know that Q metal is equal to negative 229.9 joule. Back to the question, we are asked to find the approximate heat capacity of the metal. So we can use the equation of Q metal is equal to Ms delta T. When the metal is put inside the water, the final temperature of the metal is eventually same with the final temperature of water. So we can know that the delta T is equal to 26.1 degrees Celsius minus the final temperature of the metal, which is 78 degrees Celsius. From the equation, we can know that the S is equal to 0.4430 joule per gram degree Celsius, and this is the specific capacity of the metal. However, we are asked to find the approximate heat capacity of the metal, so this is not the final answer for the question 5. For the heat capacity, we can use this equation. C is equal to Ms, which is the mass of the metal times the specific capacity of the metal. We can use the values 10 gram times 0.4430 joule per gram degree Celsius. We cut off the gram, so we can take the answer as 4.43 joule per degree Celsius. This is the approximate heat capacity of the metal, and this is the final answer for this question. That's all. Thank you.
Good morning, Doctor. My name is Kumbul Silvan, son of Thomas Silvan. My metric number is CM200162. I'm from group number 3, and now I'm going to explain about the question number 6 by applying the S law.
Okay, the equation and delta H values of chemical reactions are given below. It is given that 2 moles of dihydrogen reacts with 1 mole of oxygen to produce 2 moles of water, and given its delta H is equals to negative 571.6 kilojoule. The second chemical reaction is 1 mole of dinitrogen pentoxide reacts with 1 mole of water to produce 2 moles of nitric acid, and given its delta H is equals to negative 73.7 kilojoule. The third chemical reaction is 1 mole of dinitrogen reacts with 3 moles of oxygen and 1 mole of dihydrogen to produce 2 moles of nitric acid, and given its delta H is equals to negative 348 kilojoule. The question asks us to determine the heat reaction at 298 Kelvin for reaction. First of all, we have to determine the chemical compound which is same in both first equation and second equation. It is found that water is the same chemical compound in both the chemical reactions. So first of all, we have to equalize the number of moles of water. To equalize the number of moles of water, we have to multiply 2 with the second chemical reaction, including the delta H. So the second chemical reaction would be 2 moles of dinitrogen pentoxide reacts with 2 moles of water to produce 4 moles of nitric acid, and the delta H would be negative 147.4 kilojoule. Okay, then we are moving on to the third equation, third chemical reaction, which is the 1 mole of dinitrogen reacts with 3 moles of oxygen and 1 mole of dihydrogen to produce 2 mole of nitric acid, and the delta H is negative 348 kilojoule. First of all, you have to inverse the reaction because the nitric acid should be react as the reactant in the chemical reaction, because in the second chemical reaction the nitric acid is reacted as the product. So to diminish the nitric acid, we have to inverse the reaction to make the nitric acid as the reactant in the third chemical reaction, and the delta H should be positive because we have inversed the chemical reaction. So then we have to equalize the number of moles of nitric acid. To equalize the number of moles of nitric acid, we have to multiply 2 with the third chemical reaction. After multiplying 2 with the third chemical reaction, we would get 4 moles of nitric acid produces 2 moles of dinitrogen and 6 moles of oxygen and 2 moles of dihydrogen, and the delta H should be 696 kilojoule. Okay, after finding the 3 chemical reactions and its 3 delta H, the heat reactions, we have to simplify by diminishing the same chemical compounds in both 3 chemical reactions. Okay, first of all, we are looking at the water molecules. The water is same at both first and second equations, so we are diminishing it. Then we are moving to the nitric acid. The number of moles of nitric acid in the second and third chemical reaction is same, so we are diminishing it. Then we are moving to the dihydrogen. The number of moles of dihydrogen in the first reaction and the third reaction is same, so we are diminishing it. Then we are moving to the oxygen, which is the only one molecule of oxygen in the first reaction and 6 molecule of oxygen in the third reaction, so we are subtracting it and we would get 5 moles of oxygen at the end. The final chemical equation reaction would be 2 moles of dinitrogen pentoxide produces 2 moles of dinitrogen and 5 moles of oxygen. To find the heat reaction, we have to add all the 3 heat reactions of the 3 chemical equations. So it will be negative 571.6 kilojoule added with negative 147.4 kilojoule added with 696 kilojoule. We would get the answer as the negative 23 kilojoule as the final answer. So this is how we do question number 6, and that's all my explanation for question number 6. Thank you.
Assalamualaikum and hi, my name is Muhammad Faris Izwan bin Abu Talib and my metric ID is 2038. Today I will explain question number 7. Let's go. Okay. a question given the first order reaction A produce B has half-life of 0.122 if concentration of A naught is 0.5. How long will it for concentration of AT was 0.124? So the solution from the question we can know the half-life. So the half-life is 0.1222 seconds, and the A naught we can get from the question 0.5, and AT is 0.124, and this question want to find time T. Okay, first of all we use half-life formula for the first order reaction. So half-life equal to 0.963993 over K. So we find half-life if is 0.1222 equal to 0.693 over K. K equal to 0.693 over 0.1222. So we can get value of K. Value of K after we calculate, we get 5.6710, and after that we use this formula to find the value of time. So the formula is ln AT equal to negative KT plus ln A naught. Ln 0.124 we get equal to negative 5.6710 is value of K, and multiply to T plus ln 0.5. After that, if we can get 5.6710 T equal to 1.3944, and then we got value of T. Value of T is 0.2459 seconds. So this is the final answer for question 7. Stay tuned, and we have last question.
Hello everyone, my name is Ong Lo Xuan, and we are going to proceed to the last questions. The question states that a second order reaction involving reactant initially at 0.1 mole per liter and found to be 20% completed in 40 minutes. Determine the half-life in liter per mole per second for this reaction. From the reactions, given that the reactants will be completed in 40 minutes, therefore 1 minute is equivalent to 60 seconds, and we can convert 40 minutes to 2400 seconds. And from the questions, the reactants are initially at 0.1 mole per liter, and it is found to be 20% completed. Therefore, the initial concentration of reactants will be 0.1 mole per liter, and for the final concentration of reactants, we need to take 100% minus 20%, which is equivalent to 80%. And in order to find the final molarity of reactants, take 80% times with 0.1 mole per liter, and the final concentration of reactants will be 0.08 mole per liter. As we can see in the questions, this is the second order reactions, and for the second order reactions, there are two equations. First, 1 over final concentration equals to Kt plus 1 over initial concentration of reactants. And the second equation is a half equation, which is T half equals to 1 over K times with the initial concentration of reactants. First and foremost, sub in the initial concentration of reactants and final concentration of reactants we get into the first equations. And the equation form is 1 over 0.08 mole per liter equals to K times 2400 seconds plus 1 over 0.1 mole per liter. And the answer of K will be 1/960 liter per mole per second. Next, we need to find the half-life for these reactions. Sub in the initial concentration of reactants into the half-life equations, and the equations will be T half equals to 1/1 divided by 960 times with 0.1. And the final answer of half-life is 9600 seconds, and it can be also converted to 320 minutes. That's all from us. We hope you like it, and thanks for watching.